Hello and welcome back to Manifolds, the video series where we extend our analysis knowledge to generalized surfaces. And in today's part 46, we will look at an example of a manifold with boundary. We already know that we need this notion of a manifold with boundary because we want to formulate the famous theorem of Stokes. Therefore, it's really helpful to get a good intuition what a manifold with boundary is. However, before we go to our example, I first want to thank all the nice people who support this channel on Steady, here on YouTube or via other means. And as a reward, you can find a lot of additional material with the link in the description. Okay, then let's immediately start by recalling the important definition of a manifold with boundary from the last video. Essentially, we have the same definition as for the original smooth manifold, but now also charts to the half space are allowed. And there please note, the half space is just Rn, where the first component is not allowed to be positive. So you could say we cut Rn into two halves and we consider the left hand side. And now this half space is a topological space as well, which means charts as homeomorphisms make sense. So more precisely, such a chart is a map H from an open set from the manifold, which we could call U, into an open set of the half space, which we could call U prime. So you see, a chart is also again a homeomorphism, but now U prime is an open set in the subspace topology. And in fact, this is all we need for the extension, and then a lot of definitions and properties from the ordinary manifolds immediately generalize to manifolds with boundaries. And because these things are so natural, we did not start with this more general definition at the beginning of the course. However, in order to see what we talk about here, I think an example is really helpful. And often for an example, we can just take an ordinary manifold and just cut it, split it into pieces. For example, we can just take our sphere as 2, but only look at the northern hemisphere. So you could say we cut the whole thing at the equator, and what we get is just half a sphere, and let's call it the northern hemisphere. But most importantly, here the equator is still there, so it's part of our manifold with boundary. In fact, we already see that this should be the boundary of our manifold. And of course, to formulate that, we have to write down charts which maps into the half space. And there we should see that this boundary here is also mapped to the boundary of the half space. And there I should also see that a single chart is not enough, because the boundary here is a circle, but the boundary in the half space is a line that stretches to infinity. So in order to get homeomorphisms, we have to split this hemisphere again. Therefore, first let's write down the formal definition of our manifold here. These are all the points from S2, where the last component x3 is greater or equal than 0. And now for the definition of the chart, we also have to restrict another component here. For example, we could say that x1 should be greater than 0. Hence, we only consider this quarter now. So this is our set U, which we want to map homeomorphically to the half space. And the best way to do that is to rotate the whole thing to just project it down. Then the part we actually consider is on the top again. And most importantly, our boundary from before is now also only a half circle. So please don't be confused by the rotation, it just means that the x3 coordinate runs in this direction and the x1 coordinate in that direction. And now the idea is quite simple, we just look at the whole figure from the top and then we have our homeomorphism. In fact, this is what we could simply call a projection to the half space. So we get half a circle where the boundary lies here on the border of the half space. So please note, this boundary part here is part of our open set on the right hand side, simply because of this inequality, but the circle line is not, because we said that x1 has to be greater than 0. This makes sense for our homeomorphism, because we have an open set in our abstract topological space on the left hand side, and an open set in our subspace topology on the right hand side. Hence, we don't have any problem at all to write down the explicit chart. So it's our h from u into u prime, where we say we have 3 coordinates in u, and they are mapped obviously only to 2 coordinates on the right. And now in the picture you see that the x1 coordinate does not play any role in the projection because we completely project it down, so we only have x3 and x2. So more precisely, we don't change anything with the x2 coordinate, but the x3 coordinate is flipped. So we simply have minus x3 in the first coordinate on the right hand side. So that's it. This is our homeomorphism. It's a well-defined chart into our half space. And now you might believe me that we could simply repeat the whole construction for all the other quarters on the sphere. And then the result is that we have a whole atlas for our northern hemisphere, which is a manifold with boundary. Moreover, you also already know that this boundary is usually denoted by this del symbol. And indeed, with all the charts we have shown that this boundary is actually the equator. So you could write these are the points from x2 where x3 is equal to 0. So it's definitely not so complicated, but what you should remember here is that this is a one-dimensional submanifold of our original manifold with boundary. And most importantly, this new one-dimensional manifold does not have a boundary anymore. Indeed, in our example here, it's simply the S1, just a circle. Okay, now I can already tell you, in the next step, we will also extend the integration from ordinary manifolds to manifolds with boundary. This means that we have to extend the tangent spaces and also the orientation from manifolds to manifolds with boundary. This is not so complicated, but we should discuss it because otherwise Stokes' theorem will not make sense. So in order to understand this important theorem, we should define everything correctly. So this is what we will do in the next videos. So I really hope I meet you there and have a nice day. Bye bye.